Predicting shock in pediatric patients through thermal gradients and machine learning and multimodal approach. Shock is a critical condition that reduces blood flow, limiting oxygen and nutrients to tissues. Without treatment, it can cause organ failure and death. In intensive care units, shock affects about 22% of patients, with mortality rates between 37 and 45% depending on the type of shock. Several clinical parameters help evaluate shock, such as mental status, lactate levels, or the shock index. In our study, we used the shock index pediatric age adjusted as the basis for the outcome label, and we incorporated thermal data extracted from core and peripheral regions, together with other clinical variables as potential predictors. The data used in this work were originally collected by Nagori et al. In 2019 at a hospital in New Delhi, India. Our main contribution is the development of 4 machine learning models derived from a systematic comparison of algorithms across 4 time intervals, aimed at the early detection of shock in pediatric intensive care units using thermal gradients. We compared 10 machine learning algorithms at 4 prediction horizons: 3 minutes, 3, 6, and 12 hours. Models were evaluated with AUC and its 95% confidence interval, using a group and stratified cross-validation. Here we present the best performing model for each prediction horizon. CATBUS achieved the highest AUC at 3 minutes and 3 hours. At 6 hours, the multilayer perceptron became the top performer. Finally, at 12 hours, logistic regression outperformed the other models. This slide shows how we tuned the CATBUS model for the 3-minute prediction window. We use Optuna to explore a wide range of parameter settings and identify the configuration that perform best. The table on the right lists the hyperparameters selected. The next 3 slides follow the same idea but for the remaining prediction horizons. We show the search space used to tune CATBUS for 3 hours, the key multilayer perceptron settings explored for 6 hours where this model performed best, and the search space for logistic regression at 12 hours. For threshold selection, we use J-statistic balancing sensitivity and specificity to optimize classification performance. Overall, we obtained 4 predictive models with promising AUC values. The best performance was observed at the 3 minutes horizon, where CATBUS achieved the highest AUC along with the narrowest confidence interval.